All right, so today I'm going to talk a little bit about perf testing. And I was working on my library today, microhost, which has been in progress for years now. Um, and one of the things that I was looking at, which I don't get to do often, is I was looking particularly at performance. And today I'm just going to crack open what that looked like so that you can see it. So first of all, a lot of what I was doing was just related to scoping tickets and tasks. So once this thing loads, basically we'll go in and take a look at the backlog that I maintain. And you can spend a lot of time, whether it's in a paid job, a company that you're running, or whether you're just a technical contributor, you can spend quite a bit of time just trying to assess what to do next. And a lot of times it's a jigsaw puzzle. You don't really know what the best or most efficient thing to work on next might be. So I spent a considerable amount of time not only maintaining a backlog of to-dos, but I actually put a fair bit of work into, at least for some of my more matured libraries, knowing exactly what the research is that goes into some of these tickets. So for instance, if we pop open, I just want to make sure I'm on screen share. We pop open a ticket like this. This might not be one that demonstrates the level of research, but let's see what we got. This is one that probably took me at least 30 minutes of research. So in order to turn uh, my repository microhost into a zero dependency, which makes it much easier to host on serverless and lambdas, I went through and analyzed the dependencies of all dependencies that are there. So that gives you a level of granularity. And the other thing to say that's relevant about any kind of serious software development practice is that you can go for months without addressing some parts of your system. And you can walk into any corporate team and they'll talk about Stockholm syndrome. So people get used to the wrong things. Is kind of the reference of the Olympic Games when the unfortunately, victims were held hostage, and I think they wound up not wanting to leave their captors by the end of it. And that then became referred to as Stockholm Syndrome, if I'm not mistaken. Or it was some kind of incident with, I guess, the snipers didn't want to take the shot. Whatever it may be. People do this all the time in the code world, and they get used to crap. So, that said, I think the rational explanation when you're in charge of your own technology, you always discover the truth a little bit better. It's not just blaming the organizational structure because you get much closer to understanding that this is why things are the way they are. And so if we look at this backlog here, and this is where we'll go into the perf issues today. This particular module is just one of 1, 2, 3, 4, 5, 6, 7, and just that product alone. There's 4 other products. So there's a lot of surface area, and you can spend months at a time sometimes just running pretty quickly, trying to make progress. So those are the reasons that perf, in this instance, did not occur. So perf wound me up leading me down into a rabbit hole that we have right here. And what I found out was that, and I can give some background on the library, but basically what I found out was it was this line, altruistically, what's the right word here? It was not a terrible mistake, but this line, this code being inside of here versus out here, allowed me, or sorry, I should say, and let's do it on a particular. This became a whole pattern of errors. So, for instance, if I search for ignored files again, let's go back and actually remove that so we don't get bad perf. Let's go search for ignored files again, right here. Right. So now I'm just going to initialize the system, and we will see that not only does it take so it actually says it bootstraps the system. Let's figure out what VSCode is doing. Sometimes when you do the video and on top you do, hold on, now we're on screen share again. So it actually says it's bootstrapping the system, which is great. right here it says it bootstrapped in 3.1 seconds, and that by no stretch is anything that I really care about addressing in terms of perf. What it was doing was it was more or less delivering times, and let's try to remove some of these other patterns where it occurs. It was delivering load times that were closer to like 20 seconds. And that's where you start to get into a territory that you can't really tolerate it, especially when you're like trying to do basic tasks like pull your repository, or sorry, pull your servers down and then redeploy them. It's just not fun to wait 20 seconds. So that's where it starts to become become more irritating to wait. So now let's see. We can already notice it's taking significantly longer than 3.1 seconds. So what did I do to diagnose this? And so I think that there's all kinds of perf libraries out there that you can use. But I really am an advocate that you should never let the use of other libraries. The problem is if you over rely, and I talk about this in other videos, if you over rely on other libraries, and there's an art to picking which libraries to rely on, you can get in the habit of never trying to fix anything. You're instead just delegating all the time to somebody else. And in this case of perf, we can go into the class I wrote. Maybe no, I'd say none of this, even though there's some lines of code that got written, and sure, I wrote 130 lines in like an afternoon, no problem. This is a fairly basic pattern. And what this results with is the ability for me, so if we go back here, I think it's start timed perf. So you just drop a start time perf, end time perf. And then I did some fancy magic that's not really that fancy, but we'll pop open here. Pop open the perf file that drops. And what I found was, because I generated this, was I found that whenever I ran, well, it's maybe easier to navigate inside of a browser, huh? So we're just copying and pasting the JSON right now. Of course, there's far too much data for it to be fitting in the buffer. So what I found was that, and what's interesting, okay, so I guess I found that the get all scripts function, which again, you can kind of understand, even just the gist of what I'm saying more as a pattern of how you can perf your own software. So I guess the lessons here so far is that, the perf class that got written right here, not that difficult. It's basically just saying like, store some information that's basically time stamped. And then when it came to this save file system perf, which I'll get into in a moment, but basically this kind of wound up with this idea of like you have across the library, you have different measurements of how long whatever thing takes. So it's saying it took 10 seconds to bootstrap the whole thing. It spent only 1 millisecond within bootstrapping config. So you can kind of identify where the problem areas are. Bootstrapping secrets, problematic. Shared code, not really. Shared configs, again, you can start to identify where stuff goes wrong. So I think it was once I started to see, I believe, inside the shared files, it started to look interesting because once I dug into this all scripts where the bulk of the time was, which is 10,000 milliseconds, I then noticed if I did a stack trace that it was in fact calling this get shared files function. So I wrote a little something extra. And what's interesting here, so I think this code is actually occurring outside of the bootstrap. So if we kind of pop open what that message said right here, and it says 10 seconds, I noticed that I wasn't even able to exit the program. So it was hanging. And so basically I noticed that that's where the bottleneck was. So once you sort of start doing perf testing, and I think really just the core of it is just measure your application. You could talk about delegating to Google Analytics or something like this for your application, but I think it starts with like just come up with a good JSON format of all of your timestamps and how long stuff takes to load, what events are going on in your system that are relevant to performance. And you're not always going to need to really measure this. There's a lot of applications out there that don't need this kind of level of granularity. You might just be benefited to know conceptually how you can implement something like this. But going back to the particular use case, what I wanted to do was I wanted to dig into this get shared files because it was being called by get all scripts. So in other words, in the microhost tool, it's trying to get across the entire file system all of the scripts across all of the shared packages. So this get shared files function is where most of it was occurring, and I wanted to pop this open a little better. And by doing this, I wrote some extra code right here that basically dumps this iterations, which just says that like inside of, I guess, where is this function? It was saying that let's see, get shared files. So it's just dumping like what folder it was searching for shared files from, and then what path. And so like the raw data might have looked like something like this. So saying what folder it was searching, and then from what current working directory. And so what I wanted to do is basically group that information, which we got right here. But the interesting story that got told was that it was happening 39 times. And so that's when I found, that's when you have your smoking gun. You know what's causing the slowdown. And again, that's where I went, and we can look at this. It's not only that it was 10 seconds of load time, but then the application would hang after that. And so now that's how I was able to, if we go back and we just move these ignored, and it made perfect sense. So for every shared directory, and there's 39 of them, it was trying to run another shared files query, which is why, in other words, it shouldn't, due to the way the system's architected, it should only have to query one time per package, but it was doing it 39 times. And so that indicated obviously some kind of n squared type of iterative, probably unnecessary, processing. So just running this get shared files, for each shared direction. For each shared directory, and that really was not only unnecessary processing, not really doing anything for the system, but in terms of like finding that type of a bug, not the easiest one to find. All right, so now, all right, let's see. Let's go back into this folder. Let's just make sure. Seems fine. And so now we have the 4-second. We went from 10 seconds, but then it importantly hung, so I wasn't able to just have control of the command line. It was a hung process. It took another 10 seconds just to quit. So in finality, that's what perf in this type of context means, but there's all kinds of ways that you can try to troubleshoot it. In my case, it made sense to spend an afternoon on because that library is run maybe 50 times per day. So you want your highly iterative tasks in a day to be performant. You could analyze it from the human process and developer experience perspective. You could analyze it from the experience of what systems are doing, and if you have to load routinely a lot of data, say for instance you have to process customer information and load it into your own database, if that process is taking a huge amount of time, or it's creating bottlenecks, or you find you have to scale up to 10 different servers just to process it, you might want to start looking at perf so you don't have a $3,000 per month expense that you really don't need to be having, because that looks like $30,000 per year, and then that starts to be something that you should at least spend an afternoon on. So I hope that this video inspired you. If you want to see more, just like and subscribe.